we have the speaker Gaurang Singh here. Gaurang is a regional field CTO specializing in helping customers optimize their Kubernetes spending. He has over 12 years of experience across startups, product development, and consulting. Gaurang has a strong background in data science, blockchain, and DevOps. Previously, he served as a principal solution architect, bringing deep technical expertise to innovative solutions. Over to you, Gaurang.
Thank you. Let's do it. Okay, no. Okay, audible, right? Cool. So can you remove this? Yeah. Or maybe do it in the back. Thank you so much. That's enough. Yeah. Cool. Myself, Gaurang. I've been helping all the customers across APAC, especially in the case of Kubernetes. Our company does only Kubernetes, and we have developed our own, capabilities to manage Kubernetes. But that is not I came. This is not what I want to talk about. Is I want to talk about the problems I have seen with customers. Right, the problems majority of the customers have it. So what we did, we actually did a study, and in that study, we tried to understand what is the gap in terms of wastage, right? So we have a lot of customers. We have 2,000 plus customers. So what we did, we take a data from those customers. In this data set, we only considered clusters which are more than 50 plus CPU. So the size of the cluster was good enough to have a production grade or miniature production grade setup. We took sampling data from last 1 year, from January to December 2024. And the customer base was across all the three cloud providers. So there is no fixed pattern. It's across the cloud provider has a similar pattern, right? And when we collected and analyzed this data, we understood that there are certain key breakpoints, right? So the three most important part, especially in the case of wastage, is what we captured, and the first two are following, right? So especially when the customer connect to a cluster, we capture the data, and the data is captured in such a way that it tells us that how many compute they have. When I say compute, it lists number of CPUs. Then we also have a way by which we can identify that what is the application developer have put as a requirement. That in a Kubernetes term, it's called resource allocations, or I would say requested CPU. Then the third term is actually what you're really using, the utilization. If you're using Kubernetes, how many people are using Kubernetes? Most of them, right? So you have used one service called metric server, right? It's by default everywhere. AWS, you have to install it. But GCP and AKS, by default it comes. It's a very common standard. It gives us the real utilization, the CPU and memory utilization. So we actually start pulling the data from that also. So we collected all three parameters and did one analysis that how much customer is paying versus what is their actual usage, right? And the data is only 10% on an average. Only 10% of the CPUs which they're paying are utilized, which means that they are paying for 100 CPUs, for example, only 10 is being utilized, right? Memory is slightly better. You see 23% average utilization, but that is the pattern across the three cloud provider. It's not any specific problem. It's a generic problem to solve it, right? And the impact of that is 10x. When I say 10x, means you are paying 10 times more than what you actually using. So even though you just optimize 50%, you just, or I would say even though you just cut down your infra by 50%, nothing will happen in your infra. Just delete 5 machines or 10 machines or 50% machine, nothing will happen. But the job is not that easy, right? You just can't go and cut down your production by 50 and have nothing to do. It is more technical and more critical, and that's why the problem arises that you need a solution which can actually help you automatically and reduce your cloud bill by that, right? So let's understand more. This is a real-time example we have captured from one of our customers. It's a workload. It's a real workload, production grade. The blue line which you see is the requested CPU or the application demands, right? So your developer asks for zero point 0.3, or if I say it's 300 millicore, right? So 300 millicore CPUs was requested by customer, and once you request 300 millicore, Kubernetes scheduler will make sure it is being there. Otherwise, it will go, the pod will not schedule. It will be in pending state. So the autoscaler has to create that many capacity. And I often ask customers who are DevOps engineers, why so much high? What is the rationale behind it? And they always say, it was always like this. You know, humans are bound by habits. We assume things that, it is working in my production like this. For example, this developer might have tested this application for 2000 TPS. For 2000 TPS, he provisioned 300 millicore per pod, maybe 10 pod, 50 pod, but that is the minimum requirement. Is your all the environment of your infra is having 2000 TPS always, any point in time? No, right? It's not possible. They check for the peak. They say, okay, let me set the peak. There will be no problem. And now the problem is basically the DevOps engineer now is scratching his head that how to reduce my cost. I get the ask that, reduce your cloud bill. You are not able to touch this because developer says, hey, if you touch it, application will not perform. Why? Because they just tested somewhere down the line 2 years that, this is my CPU requirement. Sometimes it changes, like your CPU requirement was high when you started developing the application. But as and when you publish more and more code in the system, you turn out to be an either average case where CPU and memory are balanced requirement, or maybe memory is more requirement, right? So over the period of time, you basically need to keep on checking that what is your actual requirement, and that's how you do. So this was the real case. You requested for 300 millicore. The actual utilization was almost less than 100 cores, so I would say 10 to 15 cores, right? What we did, we enable autoscaler there, and it cut down the requirement to 0.14. So 14 millicore is what the actual requirement is. You see the pattern, right? The machine, the agents check the real usage and do it by automatically, right? If I ask the same thing to do the human, he can do it one. Human also can do the same. But is that how many times a day? Or how many times a month? It's very, very tedious task to do it, right? That's why the automation is the key. Let me take a reverse example, right? It's very against the saving example, but let me explain this. In our research, we also found that there are 6% of the applications who are under provisioned. When you say under provision means you artificially bottlenecking. So for example, let's suppose your application can do more than 50 TPS or 5000 TPS. You have given him less resources to applications. Why? The same reason, humans are bound by habits. They have tested in the past that this happens like this. And so let's understand what is the use case here. So there was an application, you see, the real usage was little high, the green one, right? But the memory requested was very low. And what we did, we enabled the automation on this, and boom. It got settled at very high level. This application was forcefully pressurized to not perform. Imagine this, right? You have developed an application, you have forced it not to perform. And that's what exactly the case was. It was not giving better performance. They assume this is how it is. Until they enable the automation and identify, no. The resource was less and we have to get more, right? So that was a reverse case of automation. And you see, automation works both sides. It can increase your performance by increasing the resources. It can also decrease the cost by reducing the waste. Both sides. But it is backed by data. The decision is backed by data. The data is your actual utilization. Every cluster have a different requirement. Every environment have a different case. So you just can't go by one example and implement everywhere, right? So let's move on to next. And that's what I was saying, habits. Let's take one more example, right? Habits are hard to change. So, okay, let me ask this. If I ask you guys on February, if I give you a task that you have to pick a spot node which is best for your environment, which one you pick? Any example? On February, you check the data of February only. Most likely M5, M6, M7 is better performant but little costlier. So you say, okay, let's pick M5 because I believe I used M5 and it's a cheaper, right? But over the period of time, this data is for 12 months. You see the trend? If you stick with M5 only because you tested, you said that, oh, February it was the cheapest one I know, or maybe the near cheapest, and that's why I'm using M5. No, it's not costly. It's the most cheapest solution I have. I have checked it myself. But if I ask you the same in the December, is not the case. In December, it is M6, which is the cheapest. It can be something else also. I'm just giving you one example. It can be something else. It can be M7, which is cheaper. Or maybe a new machine came into the system, which is G series. Nowadays, if you use, are you using AWS? You can find G7 is coming into the new one. If you're not using it, go and select. If you're using Spot, go and search for G series. It's the cheapest one possible today. How would I know this? Because my automation has picked it automatically and I know this. But do you guys proactively go and check every month that what is the cost? No, right? Maybe once a month. It's humanly not possible, right? You are bound to do more productive work. This is a mundane task. And just you don't do it always, right? So that's why habits are hard to change. But yeah, automation is solving this problem for you. Now, let me explain the next use case with the GPUs. We again did a study, right? If I ask you to pick a GPU, and if I tell you that you want to run an AI workload, find me the cheapest or best GPUs in the world. I don't care about the cloud provider, right? So what you will do? Okay, you will check Azure first. All three machines are there. Azure Spot have 53% cheap for A100. V100 is 47% cheaper, and the third one is 47 again. So it's good one. It's a cheaper, availability is good, fine. Azure wins. What about GCP? Same case. GCP also have availability, but the cost is not that discounted. The Spot is not that cheap. So you say, okay, let's not use GCP. What about AWS? It's almost as par as Azure, but you'll most likely end up with AWS because AWS have several other parameters also to give a flexibility to use it, right? So if AWS and Azure are same, you almost want to go AWS, right? Okay, let me give a different perspective. If I change this dynamics to a time range dynamics, right? So now, let's suppose you picked AWS. Now I ask you, in AWS, I give you a free range that go to any region you want, give me the cheapest or best AWS, right? And then I put the data from January to March to month-wise data, right? Which is the region which is best coming out in that study? And this is the result, right? The January month, the best and the cheapest Spot node was in Oregon, West 2A, right? For February, it was East, move to East, right? In June, July, it is Tokyo. Did you ever thought that Tokyo will have the cheapest GPU in the Spot? Tokyo is the notorious in the Spot. If you use it, if you have seen, Tokyo is very low availability of Spot. But in the GPU case, highly available, especially in these 2 months. Cheapest solution possible, right? Then you move to Seoul, which is Korea. South Korea is the next candidate in the list, right? And the list is going on, right? So this is the data we got. But do you want to know how much? Do you want to know this? Okay. This is the difference. Imagine if I ask you to run an AI workload on GPU and ask you to give a task that give me a cheapest possible. If you know this data, you can get GPU 10 times cheaper. And that's a big factor, 10 times cheaper. And the list is ranging from 10 to 3.7. But if you have this data in front of you, you get the best and cheapest solution. And one of our clients actually have $1 million saving like this, just by having this data. Just imagine how powerful it is to do automation, right? And this is the trend. If you want to see the trend, you can go to cloud provider and do it by yourself also. There's nothing rocket science here. It's just the data and data-backed decisions, and the decision has been taken by the agents who are running and using this data. And the power of the automation is like this. The automation, the agent has been given the task that you have to find the cheapest solution possible. Give me, I don't care about the region. Give me the cheapest because I want to run my training job as cheap as possible. And that agent basically went on the shopping throughout the world and get me different regions. Right? It's difficult to set up. Obviously, yes, if your workload is in US, you don't want to go to Korea. It's time nanosecond difference. But if I give you a free hand, this is what you have it, right? Even though same continent you can work. So what is the best? What is the outcome? If you are data driven and you have the knowledge, you use the automation, you can get the benefit of running GPU somewhere between 2x to 7x, right? Compared to on-demand price which you are paying as of now, right? So that's the impact of the automation, right? And we all discuss, right? This is the key. Who is doing this? It's by automation. Now, what else, right? You solve the problem for GPU, you solve the problem for other, but what about the bare CPU and memory, right? There also the rev stages. This is the cluster managed by an automatic agent, which is backed by AI and the inheritance and the data which is already present. How sharp the peaks are. Just have you seen this? The peaks are super sharp, which means I'm not wasting any resource. I'm not paying anything extra to the cloud provider. I'm just paying what I'm using, and that's how sharp the peaks are, right? Okay. So the one which I showed you is the most optimized case. But when you start, you are like this. So let's understand what we have. So the y-axis is basically number of CPUs, okay, and the x is time. It's probably a daytime, right? So what happens? It's a e-commerce customer of ours and have a trend, right? So in the daytime, early morning, you are sleeping, right? So you are not using it. So there is no usage here, very low usage. But when the day starts, you see orders are increasing. People start ordering breakfast, people start ordering food. So it goes morning very peak, then little bit go down again, and then goes up again in the afternoon and evening time, and then in the night settle down again, right? This is your actual pattern of utilization. You name it any customer who are customer facing role, be it e-commerce, be it social media, it's the same pattern. Maybe social media is little different. Night time is more because night time we are watching more Instagram and Facebook. Daytime is less because we are working, right? Maybe Gen Z have a different pattern, but yeah, most likely you will have this pattern, reverse pattern. Gen Z will have the same pattern. Jokes apart. But yeah, this is a common trend, right? You use more. You see the blue line? This is what you're paying to the cloud provider. So this is the CPUs you have in system. You are low here somewhere down the line, but when you rise it, the autoscaler typically add capacity, right? So it's adding it, which is good. We need capacity, we are adding it. But what happens in the afternoon time? It's not going drastically low, right? He's out of shape now. And the same trend follows, and the night slowly it's going down. I'm not saying the autoscaler will not go down, cut down this capacity. Is the time matters. Let me give you an example. What is the waste here? How much? Any blind guess? What is the savings we are doing if you go better optimization there? Just keep the number in your mind. Just guess it, okay? I'll show you the correct or maybe the optimized state, and then we'll discuss about the number, right? This is the automation. You see how sharp we are, especially at the end of the day. The waste is too dominant at the end, start to end, and we are very close. Give me a number. Anybody want to guess? 10%, 20%? What is the cost saving? Yes. 60%. Okay. Anything else? Just guess. Yes. Okay, he's close. Okay, 40. Who's else? What else? Okay, the actual number is 40%. Just by managing correctly. Let me give you a perspective. If I save you a 40%, if you have $1 million bill per annum, which is common, any mid-sized company is paying 1 million very commonly. I save you 400K. 400K budget is freed up, and you know the possibility of what you can do next. Most of the company want to use that money into the AI and LLM, finding what use case they can work, but GPU is so costly. They are not investing now. The 400K is free now, and you can go for a solution. Just imagine that power of saving. And you are not, I'm just saving waste, right? I'm just reducing waste. I'm not doing anything extra, just reducing waste. This is the money you're paying to AWS and not using it. Yeah, any questions? No? Okay, sorry. If you have any question, just you can ask me at the later part. Okay, next automation is selecting the right machine at the right time. When I say selecting right machine at the right time, you have to understand what is your requirement at that point in time. Typically, when we set up the autoscaler, most of the people who are DevOps people who have set up the autoscaler, they have 1, 2, or 3 node groups set up by 1, 2, or 3 types of machine. What you're trying to do is you are creating a homogeneous groups where you basically adding a same size of machines blanket. Same size, it's a homogeneous setup. Your workloads are not homogeneous. Your workloads have CPU and memory. Some are CPU intensive, some are memory intensive. So this is basically become a heterogeneous setup, right? Now you are trying to set up, fit this heterogeneous to homogeneous. How can that be optimized? Right? So you have to have a mixed bag of machines automatically decided by automation and come to a conclusion. Let me explain what we are having here, right? So the left side is what you had earlier. You have same type of machines. You see, right? First 3 are almost same, right? And the next is spot nodes, maybe different, but it's a homogeneous setup. I had multiple node groups, so I have different type of machines. The cost of this infra was $4,300 per month. What we did, we get to a more heterogeneous setup, and the cost becomes 1,400. What is the reduction? 67%. 67% of the cost of this cluster went down just 18 minutes. You see the time also on the top. 18 minutes, 67% cost cut down. And I'm saying it's not magic. There is no magic here. If I ask a developer to do it, he probably can do it, but he cannot do 24/7. Just imagine that. At this point in time, if you ask a DevOps engineer, a good DevOps engineer, he probably can do this by breaking his mind, understanding machines, putting everything together. He can do it. But can he do it 24/7? That's the difference. That's the power of automation. The engine or the agent is working 24/7. This agent doesn't take a break, don't eat food, don't sleep. Works on the cluster 24/7. That's the difference, right? And automation is always in any field of DevOps or anything. Automation always wins over human. Okay, let's move on. The last I have is distribution of spot nodes. Spot nodes are very, very popular in terms of their bad behavior, that nobody wants to use spot in production. How many people are using spot in production? Oh, so very good. You are the 1% of the entire crowd. So very less people are using spot because spot have no life cycle guarantee. So you have to do the tuning in the application. Definitely yes. Your application has to be robust. It has to shut down itself within 30 seconds. Those are requirements of Kubernetes by and large, by anything, right? If you want to scale up and have to be agile, your application has to start faster. So once you have that capability, you can actually move your non-stateful or stateless applications to spot nodes. Have them quickly recovered. You have 2 minutes in AWS, 30 seconds in AWS, in GCP and Azure. The best part is what we do different is price arbitrage. You have seen, right? I've shown you the spot price difference between GPU and different spot machines, the trends. You can pick cheapest spot. If I ask you to do it, you can pick it today. But you cannot tell me that it will be cheaper next day also, or next month, or next year. That's the difference, right? The engine continuously poll for the spot prices. And at this point in time, which is the cheapest one for me, I'll buy it for you. And that's the automation we do it. The difference is almost, I have the number 40%. Right? So if you give me a full spot node, by and large 30 to 50% can be reduced just by price arbitrage. By picking the right machine at the right time, which is the cheapest. Right? So that's it for me. Have any questions? Happy to answer now. Yes.
The AI can change the instance type from one type to another, right?
Yes.
Say for some unknown reason, it has resulted in a production issue. Okay.
Yes.
So like this, your cast AI will take the accountability of that.
Yes.
So
So
there will be a contract.
we have to understand the issue, right? What is, when you say production issue, it's a broad term.
A customer impact. It resulted.
Now
in a
again,
customer
it is a broad term. You have to pinpoint me, tell me that this is an infra issue, right? I'll explain means. In that particular case, what could be the infra issue? It can possibly the case that your application is under provision or put into a node which is smaller. Why? Because you requested less CPU. So that's why we developed one more solution after autoscaler, which is workload right sizing. The workload right sizing basically check your pattern. And your historical pattern, we capture it, and we let you decide what's the percentile you want to set. Now you say, it's my P0 application. We do P100. So whatever the peak you have in the last 7 days, that is the requested CPU you're going to set. Right? So in that case, there can be outliers for this, definitely yes. But for that outlier, do you want to keep 50, 60, 70% over provisioning the system 24/7? That is the decision management had to take. If management want to take the bite of 70% cost just for one outlier, be my guest. Yeah, that's all.
Thank you.
Yeah. Any questions? Yeah. Previous slide? Yeah, I'm able to hear.
Size will be changed.
Yes.
So for example, I have a node having E2 standard 8. Now if you change it to E2 standard 4, for example.
Yes.
So create a new node pool or that node, because you said,
In cast AI, we don't believe the concept of the node pool.
oh, so we all nodes.
Yeah.
different nodes in
The example I gave you, right? Homogeneous versus heterogeneous. With a node pool, you cannot do heterogeneous setup.
Yeah.
So in cast AI, we never do homogeneous setup. We create standalone machines and add to the cluster. We give you a visualization of homogeneous, like for given node pool, when I say node selector, we'll give you a virtual isolation, definitely yes. If you want physical isolation, definitely yes, I'm going to give you. But if you ask me, no, bound to me a node pool, no. In cast AI, we do not believe that concept. That's a very old technology. I think cloud providers should change that technology also. Yeah. Any questions? Yeah. Oh, we can discuss in the booth. Pricing is not, we cannot discuss now. Yeah. Let's talk technology. Yeah.
Am I audible?
Yes.
Okay. You said like you are optimizing the cost based on the actual utilization.
Yes.
For example, going by your own example, like say you said press raised a request for 100.
Please, Mike. Yeah.
Okay, the pod request is 100 VCP, 100 M, and I have 100 pods running on my machine.
Okay.
So basically, my machine should have 30 CPU for all the pods to be scheduled, or else it will not be scheduled at all. How is your tool optimizing? Say they are not actually using a whole 30 CPU. The utilization is, as your own terms, 10%, and they have the pod request is 300 M. I mean, basically they are reserving the whole 30 CPUs.
Yes, yes.
How is your tool optimizing?
Yeah, that's a good question. So you are asking, let me reiterate. You asking me that you are requesting 3 millicore, which 300 millicore. You have 30 pods. Combine them to put to a one node. Typically in Kubernetes, you are not believing to have everything in one node. You spread the load, multiple nodes. So basically what CastAI will do is it will try to get multiple nodes in the system. So let's suppose 30 pods become 20 pods. You cut down 3 machines in the system and keep it everything first. Now, second is workload right sizing. If I'm not using, I would say 300 millicore, just using 10 millicore, it's better to right size to somewhere around 50 millicore.
Yeah, I mean, the question is how is your tool optimizing?
Oh, we change it at the pod level. So we have a engine which basically continuously generating recommendations, but at any specific point in time, we inject our settings to the pod, and we just change the request field of that pod and deploy the cluster. So the pod is created, we inject our settings, and the pod gets scheduled. So it's fully automated. You no need to do it by yourself or change the YAMLs, deployment files again and again. Yeah.
Thank you.
Any more questions? Yes.
Supposing we manage our deployments using GitOps, where we need the desired state to be, or the actual state to be the desired state.
Yes.
How do you manage the modification of the
So that's what I said. Our solution is mutating webhook. If you have used the term mutating webhook, it works in a post-mutation formula. When I say post-mutation means the control plane creates the definition of the pod. And just before deployment, we go and inject our settings. And that settings transferred to scheduler. Scheduler checks the requirement and pick the node. So that's how it happens. The GitOps basically sync with your deployment object. So in Kubernetes, you have multiple objects. So if you describe the deployment, you will see your settings. So GitOps try to match the settings there. We play around in the pods. So that's why there is no conflict in the GitOps versus this, because GitOps value will always be there in the deployment. So if you try to see in our solution when installed, if you describe the pod, you get our values. If you describe the deployment, you get your values. Okay, cool. Any questions? Further? Awesome. Thank you. Thank you so much, guys.